lead developer at Codebase here in Savannah. This session features side-by-side presentations and will last approximately 45 minutes with 15 minutes for Q&A. To kick things off, I'm going to introduce Kevin DeWalt. He's CEO of Prolego, the Enterprise AI Accelerator. He's also creator of the AI Canvas and author of AI for Business Leaders. Round of applause, please.
Thanks. How's this? Sound quality good? Excellent. Okay, so Kevin DeWalt, I have a startup consulting company called Prolego, and we work with Fortune 500 companies helping them adopt AI technology. So not the super sexy stuff like self-driving cars that you hear about in the media. It's lots of meetings and lots of time with data, but interesting problems and really smart people. So I'm going to go introduce my co-host. Ben, you want to introduce yourself?
Hey everyone, my name is Ben Kromnick. I'm the CTO of Esteem Therapeutics, which is a local startup here in Savannah. Are we doing just ourselves for now?
Sure, or Esteem too.
Sure. And Esteem's a behavioral health and big data company trying to solve some really big problems in the space, mostly around ADHD. And go Eagles.
Hi, I'm Kevin Lawver. I am the CTO at Planted. We are a hybrid recruiting platform, and we try to help startups hire the best non-technical talent and help that non-technical talent break into startups.
Okay, thanks everyone. So I'm going to start off talking a little bit about some of the practical issues around AI. This is a presentation that I've given to Fortune 500 executives around the country throughout the past year. And whenever I talk about a technical topic, my goal is to give you actual skills you can use. So rather than have us ramble about ideas and topics, I want you to come out of this knowing things you could do that you couldn't do before. And there's two things that I want to try to have you get out of this first 15-minute intro. And the first is I want you to understand what AI is, because we hear this term people throw about it. You're probably wondering, I'm not quite sure what that means. Is it Siri, self-driving cars? I mean, there's all these words, and I want you to understand when somebody says AI, that you can actually understand what they're talking about. And the second is to help you identify opportunities, and so that when you're talking about you have a startup idea or you're in your own company, that you can look around and say, you know, this might be a situation where I can apply AI. So let's jump right into it. How many people have seen this movie? Okay, what's it about? Somebody tell me. What? Falls in love with his phone, right? AI falls in love with his phone. And most people you will run into in the business world, when they start talking about AI, they're going to be thinking about something like this, right? And that's structured data analysis, which is quite useful, but not nearly as exciting. So this is the future that people are thinking about, and really that this is fiction, right? We don't have dates on our phones yet, but that's where most people are oriented. And so when they hear about this technology, their mind goes to, that's not relevant for me. Like this futuristic things that people in Google are doing, but it doesn't really affect me now. That's not what we're going to talk about today. Today we're going to talk about actual practical things you can do with this technology and how companies are actually using it. So this is going to kick off some definitions here. The term AI is just a general term that means smart computers. If you want to call your pocket calculator AI, have at it, right? So I use this term when I'm deliberately trying to be general, like saying computers or the internet. But beyond that, when you're trying to any kind of business context, it doesn't really mean anything. So if people start throwing around the word AI, you kind of have to first ask them, really, what do you mean by AI? So it's just a general term. The terms that matter is machine learning. And I'm going to explain to you what machine learning is. So AI is sort of the most general term for smart computers. Machine learning is a type of AI, and deep learning is a type of machine learning. So AI, machine learning, deep learning. How many people have heard these terms before? Have heard all three? Okay, so you hear all these terms, people throw them around. You'll be in meetings with people talk about their database, say, oh, we should throw machine learning at this thing, right? So people throw these terms around, but I really want you to have an understanding. So before we can explain what the real innovation is here, I have to get you to understand what machine learning is. Okay, so let's talk about what machine learning isn't. This is how 99.999% of the software in the world is written, where a programmer sits down at their computer with a text editor and starts, typing stuff and typing things into the computer and types numbers and words. And let's pretend that we're trying to we're building a drink recommender for Coca-Cola. This is actually a presentation I gave at Coca-Cola. And we want to write a drink recommender. And we're going to have a series of rules that runs through and says, does the person like this? Do they like sweet? Do they like sugar? How old are they? How much weight? And we would be able to have a little bit of rule system that would make a prediction of the type of drink that people want. Now, obviously, this isn't serious code. This is silly pseudocode here. But if the likes sweet score is greater than 5 and the likes orange score is less than 2, and they're not concerned about sugar, then recommend Sprite. Okay, and so that's a piece of software for logic for recommending Sprite. So here's my question: when the programmer sits down and starts typing this, how do they know to put the number 5 for the like sweet score? Like, how do they know that it's got to be greater than 5? Anybody? How does the programmer know? Statistical. Okay, but where do they get statistical sample from? Someone tells them. That's it. That's it. That's how programmers work. Like the programmer, product manager, boss, spec, customer. What do you want me to build? And that's how almost all of your business software, all software in the world is written, right? Somebody tells the programmer, or the programmer guesses, and which doesn't usually work out that well, but that's how most software is written, where the programmer somebody has to tell the programmer what to do. Anybody, what are the problems with writing, what problems could arise from writing a system like this, building a big complex system like this? Go ahead. Maintenance, right, hard to maintain, potentially brittle, lots of assumptions. And so generally speaking, people are excited about a different way to do technology because building big complex systems this way sometimes doesn't work that well. And also doesn't work very well for a certain type of problems. Now we're going to talk about machine learning. In machine learning, the programmer doesn't ask somebody what to put in the algorithm. The machine learning programmer uses data to train an algorithm. So just wrap your heads around that for a second. Instead of actually deciding what code to write, the engineer takes pieces of data and trains an algorithm how to make predictions. So let's try to solve the same sweet prediction algorithm we did before using machine learning. So imagine that you have thousands of people and you know something about them. You know how old they are, you know what meals they've eaten recently, you know how much they like sweet food, you know where they were born, you know all this information about them, and you know their favorite drink. You know that the young woman on the left likes Mellow Yellow, you know that the 5-year-old boy in the middle likes Coke Zero, and I was told by Coca-Cola that that's not apparently a very popular drink among 5-year-old boys, but and then the woman on the right likes Barks A&W root beer. And if you know what they like and you have all the information about them, you can train an algorithm to predict what somebody else may like. And in the case of the Mellow Yellow, the Coke Zero, or the Barks, that's what we're trying to predict. And then when this new strapping young outdoorsy guy comes along, we can plug the information about him into our algorithm, and it spits out the recommended drink is Diet Coke. So that's machine learning in a nutshell. It's using data to actually program computers. Okay, so the key takeaway that I want you to understand from this type of programming is that the Mellow Yellow, the Coke Zero, and the Barks, those are called the labels, the training sets for this data. So to be able to build a machine learning algorithm, you first have to have some sort of labeled data. And that's why the most expensive, the hardest part of AI is data. It's getting sufficiently large samples of training data. So when if a startup comes running to you and says, I got a great startup idea, I'm going to do AI for XYZ, the first thing you should ask this exciting entrepreneur is, where are you going to get the training data? That's the hardest problem in this technology. Okay, so let's talk about deep learning, which is really the real innovation in AI. Anybody want to give me a definition of deep learning? Anybody tell me what deep learning is? Go ahead, in the back. Yeah, I'm gonna say yes because I think, but I'm gonna word it differently. But I think you're saying the same definition, but I'm just gonna use maybe different words. But yeah, so neural networks, right? So The deep learning, if you haven't read, if you want to actually know about the history of this, a great article that came out in New York Times Magazine, December 2016, about the Great AI Awakening. It has the history of this technology. So deep learning is a new way to do a machine learning. It's a type of machine learning, and the history of this technology is that it's built on neural networks, like you said. Neural networks are a new sounding cool mathematical algorithm, but it's decades old. People came up with this idea in the 1950s, and about every 10 or 15 years since then, the world gets excited about neural networks. They throw a whole pile of money at it, and it always disappoints. And this had been going on for decades. When I was a grad student at Stanford, I studied neural networks, and I was all in the neural networks, and I was going to learn how to predict the stock market, and then we went through another AI winter. And this cycle's been going on for decades. And around 2011, 2012, some folks at Google said, hey, let's solve machine translation with neural networks. And everybody went, wah, 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 like we've been there before. But in this time, they decided to do something differently. They decided to take gigantic neural networks, way, way, way bigger than anything that I worked with as a grad student. When I was a grad student, I would use neural networks that were like 5 neurons, 10 neurons big. They decided, what if we take 100 million? Massive, massive algorithms. And what if we take lots and lots and lots and lots of data, like tons and tons of data, and because this data is so big and it's so hard to do the training of these algorithms, let's use a specialized type of hardware called a GPU. So when we talk about deep learning has 3 components. It's huge algorithms called neural networks, 100 million neurons, massively complex networks, lots and lots of data, and training them on a specialized hardware called a GPU. Anybody know what a GPU is? What's a GPU? Yeah, graphics processing unit. So what? Anybody know why we use a GPU for training? Go ahead.
It allows parallel processing.
Yeah, exactly. Parallel processing. So massive. So the same mathematical computation, the same matrix algebra you have to use to render, the video game. So you can see Nick Foles throwing touchdowns on Madden 2019. That same, for those of you who picked up on that same mathematical algorithm is the same one needed to train one of these gigantic neural networks. So I've got a fairly new MacBook Pro here. It would take me a week to do the training of a neural network on this machine that I can do in 1 hour on a GPU that I can get from Best Buy for $500. So it's that level of computation. So it really makes a huge difference. And when you throw these 3 things together, the world changed. And suddenly some extremely hard problems in mathematics and computer science started to become solved. We're going to talk about some of those domains, but I'll give you an example of one of them right here. So people have been trying to do machine transcription, so spoken text translated to words, and there's lots of different contexts people are trying to do machine translation. It's one of the most common computer science challenges that people have been working on for decades. And when I was working with this technology 10, 15 years ago, we were nowhere near human level of translation. And almost month after month for the past year, Google, Facebook, Microsoft are all publishing papers and competing to keep beating the benchmarks. And now they're getting to the point on some challenges where it's even better than human. So we're rapidly reaching the point where this technology is solving some fundamental problems. In terms of a business context, this is why these neural networks make a difference. So if you kind of look at the X, Y axis here, on the X we have data, which is the amount of data you have, and data goes up as you go right, and you have the performance of an algorithm on the left-hand side. With human beings, you add more and more data. Once I see a picture of a new animal, like the first time a child sees a zebra, the second time they see a zebra, they can pick it out of the picture, right? Because we have intuition and inference. So we're pretty good with small amounts of data. But as you throw more and more and more data at us, we don't tend to get better. In fact, given the age that I'm at, I think my slope is starting to go down to the right actually. So you throw more and more data at me, and I get worse. Traditional machine learning algorithms, the stuff that the researchers and programmers have had for decades, they do better as you add more data, but at some point they have a tendency to plateau. But in deep learning, it just gets better and better and better. So the more data you throw at it, the bigger the algorithms, the more computational power, they get better and better and better. So that's a quick overview to deep learning and AI. Deep learning is the most interesting, is the real innovation in AI. And so when people talk about AI, and almost anything they're doing is going to have some sort of deep learning. Otherwise, it's probably not that new and probably that interesting. And deep learning has 3 components to it. Very, very big neural networks trained on a special type of hardware called a graphical processing unit, and using tons and tons and tons of data. And so that is the basics of AI. So first goal of today, I wanted you to be able to understand when someone says, what is AI? Now you've got a sense of roughly what they're talking about. And it's not Scarlett Johansson being your magical date on your phone. I know, rats. Okay, so the second thing I'm going to talk to is I want to just talk about like some applications. The number one challenge that we run into with this technology when we go out to talk to prospective clients is they don't know what to do with it. Like I can get up there and I can talk about GPUs and AI and algorithms and and all these interesting concepts, and and after 15 minutes their eyes gloss over and they go, okay, what can we do with all this? And so making that leap between what the technology can do and how to apply in a business case is our company's biggest challenge, and it's the biggest challenge in the industry right now. And so what we've done is we've tried to identify 4 product patterns of ways so you can start thinking about how this technology is being applied. And so I'm going to discuss the 4 of those with you using examples from Coca-Cola. So the very first product pattern is called computer vision. Anybody want to give an example of computer vision? Anybody do any computer vision projects? Something they've seen? Anybody? OCR, yeah. Go ahead. OpenCV, yeah, there you go. Anybody have any computer vision in their pocket? Like the iPhone 10? So facial recognition, obviously one of the big uses of computer vision. Right now, this is the most advanced AI technology that we have. So of all the things that I'm going to talk about, this has been the one that's been leading the forefront and is the closest to is the furthest, the most mature, I guess you could say. I worked on facial recognition 10 years ago with the U.S. Intelligence Community, and I expected to have the kind of things in this phone around 2030. And I'm just shocked at how good it is. And if you don't have an iPhone 10, it can be middle of the night when the phone can't see half my face, and it can still pick out who I am. So it's pretty amazing. So a computer vision example, imagine if you have a vending machine, and when somebody walks up to the vending machine, the vending machine can actually see a picture of who's in front of it. Is this an individual? Do they have cash in their hand? Are they looking around to lots of different, are they looking at different choices, or do they know exactly what you want? There's all kinds of information you could imagine a camera watching somebody in front of a vending machine could learn to be able to use towards purchasing decisions. Another one, this is one that Coke is actually doing, but they scan your Instagram feed and look for photos, and when they find a photo or an image, they try to draw conclusions about what you may like and what ad to show you based on what's in the photo. So if you're sitting around bars a lot, maybe they're gonna give you a Coke, and if you're at the beach, it's a Diet Coke. I mean, I don't know how they would tune their algorithms, but they would be able to show you different ads based on information you see. Anybody do any kind of computer vision work, experience anything at work? It's becoming more and more popular as technology. Go ahead. Okay. Okay, cool. Right. And what kind of algorithms are you using? For plays? Okay. Okay. All right, okay. Excellent. Yeah, common. So ImageNet is an image database that is open. It's got 1,000 different categories of images, and it's a good starting point for building computer vision recognition algorithm. So is that a picture of a dog or a cat or a fish, or what is the thing in the picture? And it's better than human level accuracy now, the algorithms are. So that's the first pattern. Let's check, time check, how am I doing? Okay, I'll try to wrap up soon. Okay, the second one is collaborative filtering. How many people are Netflix subscribers or know what Netflix is? This is how, yeah, everybody now, right? Yeah, stupid question, right? That's how Netflix recommends movies to you. When Netflix first started out 10, 15 years ago, they would recommend movies on Do you like foreign films? Do you like independence? Do you like do you like romances and rom-coms? And so but most of our movies takes and our movie like most of our our movie tastes are not easily lumped into particular buckets of types of movies. When it's Friday night and we're sitting in front of the TV trying to figure out what to watch on Netflix, and the word rom-com comes up, I throw a fit. Like I'm a little kid jumping up and down saying, no, I don't want to watch some stupid romantic comedy. Like, this is torture, right? Unless it's got like Ben Stiller or somebody cool in it, right? Then I'm all into it. Or Vince Vaughn, right? So like if you had to look at my what I like on my Netflix, you'd be able to draw some sort of parallel that says Kevin likes romantic comedies if they have these certain types of actors. Well, you can imagine trying to program that would be really, really tough. So what collaborative filtering is, it's trying to make a prediction of the type of products you may want based on what type of products people like you have bought in the past. And so it's a way of making predictions. If you have thousands or millions of customers and you have thousands of products, it's a technique for making a prediction of the type of product somebody would want. And you can imagine, what kind of promotion should we offer, based on everything we know about customers. Lots of this comes up. Almost every e-commerce site, almost every product site can use some sort of collaborative filtering. Okay, next in event sequence, so structured data, sales data. Another really common business problem, how much toothpaste are we going to sell in the grocery store next month? Trying to make predictions of, based on a time sequence of events, what's going to happen next? How many things are people going to buy? What ad should I show to this person? What is the link they're going to click on in the screen likes? So next in sequence events is the third product pattern. And the fourth one is natural language processing. Anybody know what natural language processing is? Go ahead. Sentiment analysis is a type of NLP. Yep, I'll say NLP. Say NLP and it sounds cool. So anybody, another example of NLP, or want to give me a definition of what NLP is? Speech recognition, a type of NLP, right? So it's basically trying to draw information or intelligence about naturally written language, right? So unstructured text that's in a document. Most of the information we have in this world, all of our legal documents are all unstructured. You don't have every word in the column in a database. It's a big pile of text and people have to read it and understand it. So that's what natural language processing is. And here's an example of, just like you said, sentiment analysis, right? So is this person on Twitter saying something disparaging about Coca-Cola, and should somebody respond to them? It's a common NLP type of problem, sentiment analysis. This is the most, I was going to save this for the Q&A, but this is the technology that I think is the most exciting. Of all the things that are coming out in AI, this is the one that's going to have the biggest impact, and it is changing incredibly fast, almost month by month. The rate of NLP is really, it's an exciting time. So the impact it's going to have on almost every business process, on contracts, on laws, on pretty much any time you have a human being that's interacting with a piece of text is an opportunity for NLP. So incredibly exciting time. That's it. So that's the AI. Those are the AI basics. So 2 skills I wanted to leave you with. The first one was to understand what AI is, right? In AI, all the innovation in AI we said is deep learning, and that's 3 things. What are the 3 parts of deep learning? Who can remember? GPU and? Lots of data and? There you go. Lots of neural networks. Yeah. Big neural networks, big data, GPUs. Awesome. So that's the basic of really the innovation that's happening in AI. And then there's 4 product patterns. Who can list all 4 product patterns that I mentioned? Which one? Anybody want to try all 4? Who can get all 4? You don't know? You took notes. Okay, let's go through them together. So first, somebody name one of the patterns. Computer vision. Collaborative filtering. Next in sequence. Good, that's one of them, Fritz. And NLP, right, 4, awesome. So those are 4 product patterns you can use as you start looking at your company and your work to look for potential areas where you might be able to apply deep learning. So with that that sort of wraps up the presentation part of this. I'm going to just take a few minutes for questions on what I just presented, and we're going to have time for general questions in a few minutes, but I want to give Kevin and Ben a chance to talk about their work. But any questions about sort of the basics AI stuff, the kind of topics I've heard, okay?
Where does all this data come from and how is it aggregated? Like, what are the sources of data when we're talking about all of that?
Okay, when do you guys want to take that? What are the sources of data?
One, there's a ton of open data out there. Like, we were just looking this morning at the Bureau of Labor Statistics and how they have every occupation you could ever have in Excel sheets. Like, there's a surprising amount in CSVs and Excel files. And then the rest of it is behavioral. Like, it's your likes and what you look at on Facebook. It's all the Google Analytics, all the pages that you visit on. So it's all like the collaborative filtering all comes from what people do on your product. So like, if you're not tracking that, then you're gonna have a real hard time training an algorithm to do anything with data you don't have.
I just want to add one quick thing to that as well, is sometimes there's actually companies who their entire business model is around creating labeled data. So for instance, Kevin brought up the legal space. There are companies that actually specifically make human-labeled, expert-labeled legal documents, because there's an awful lot of Latin in legal, and there's not a lot of good training data in Latin. Or the same thing exists in healthcare as well. If you want to look them up, there's a company called Transcribe Me up in Berkeley. And so, one last thing. At Esteem, we actually are having to create our own data. So sometimes the data just doesn't exist, which means you have to build into your business model. There's a ramp-up period of really bringing value to the market that is separate from the machine learning value. And that's a huge challenge oftentimes, and it's why you've seen companies like Google, who start off with, we just link two websites together, use that as their ramp up to do all the other smart stuff that they do and create all the massive data sets that they've used for their machine learning algorithms.
Good question. Go ahead.
So I didn't understand what a neural network is.
Yeah, I usually don't go into that because it gets to be like really techy, but but I'm going to actually, so it is, so you've seen from algebra y equals mx plus b, like y equals mx plus b, that with a little bit more complexity to it. But as a mathematical algorithm, it is shockingly, it's shockingly simple. And so when I'm surprised when engineers actually sit down and look at the math of a neural network, they all have the same reaction, like, yeah, that's it, and that's basically it. So it's a bunch of connected sum equations. So a plus b times x times 3 times y, and if you write that out, it's a neural network. Math-wise, it's really not that easy. It's all the things that have to go around the math. And if you want to talk to any more of them, we're gonna stick Justin on you. So Justin will be happy to tell you what a neural network is. Go ahead.
So there's a really great YouTube channel called 2 Minute Papers, which kind of like spends some time thinking about deep learning and AI. I totally recommend everybody to sort of subscribe. Really great understanding of sort of everything you're talking about too. But it kind of sounds, we can probably make faster GPUs and bigger neural networks.
Mm-hmm.
But it sounds like a really quick limit that's going to hit in terms of like the amount of people having to work on creating these data sets. So are there any solutions
Yeah.
for unlabeled data sets possibly?
So this is it's a huge problem. We get this from our clients all the time. There are techniques that you can use. The most common technique is called transfer learning, and it basically means find a data set that looks kind of like what you want, pre-train your algorithms on that, and then fine-tune it on a smaller data set. So the gentleman mentioned ImageNet before. ImageNet's a freely available data set. You can download it on your computer, and you can train a computer vision problem on ImageNet. And then you can take pieces of that network and the weights in that neural network and retrain them on a smaller data set. I did this for a client, and we estimated it was going to take about 1,000 labeled examples to do with each one they wanted to do. We found a data set similar to the one they wanted, trained it on it, and then we realized it would be about 100. So we lowered their cost by a factor of 10 just by doing some fairly simple techniques. And then we sounded really smart. So, but it really wasn't that hard. So I want to give Kevin and Ben a chance to talk about their work now. So let's jump into that. We'll do more questions towards the end. So who wants to go first?
Hey guys, Ben Cromnick from Esteem Therapeutics. So just kind of piggyback off of a lot of stuff that Kevin talked about. I want to talk about what we're doing at Esteem as a way to talk about the machine learning, artificial intelligence journey that a lot of companies go through. I'm going to hit on a couple things. One is obtaining labeled data sets. Another is identifying opportunities, like Kevin talked about. And a third is kind of around governance and ethics. Because a lot of the industries that we work in and a lot of just generally the application of these technologies carry with it ethical complications. So at Esteem, like I said, we're a behavioral health company, and we make a technology and a platform and experience that we think closes the loop that exists generally in healthcare, but we're really focusing on closing the loop in behavioral healthcare. What that means is often today, parents receive a diagnosis of their children saying you have ADHD or ADD, and sometimes they're given medication, sometimes they're not, and they're sort of asked to kind of feel things out, but they're really left on their own. Yet there are often so many players involved in this ecosystem of care that it's not just the pediatrician, it's not just a therapist if they're lucky enough to have one or be referred to one. It's things like a physical therapist or a teacher or grandma or grandpa, the soccer coach, the physical therapist. So it's this really immense and complicated ecosystem of people that exist all around this one person. We're just trying to make this one person have a rich, fulfilling life. So what we've done is we've created this platform that kind of gets outside of the traditional healthcare infrastructure, which is anchored in these massive electronic health records and within insurance networks and within physician networks. And what we've done is we've empowered the parent to instill accountability to each of the people in their ecosystem, but also to what we say they take control of their diagnosis. It's no longer my son or daughter is ADD. It's my son or daughter is struggling with these specific tasks that a typical child at that age would be able to complete satisfactorily. And I'm sitting here staring at my CEO off in the corner, who is a very esteemed clinician, so I have to be very careful about words that I use. But one of the things that we do is we really enable, he throws things, it's scary. But one of the things that we do is we really put metrics around this really confusing and emotional state that is a child that doesn't look like what you think everyone else's kids look like. It's this very emotional experience. So we actually we create data where data didn't exist. So today most health assessments in general are pen and paper. If they're not pen and paper, they live off in a deep dark database in an EHR record and is never used. That information so often has so much utility, but it's never accessed. We have a mission to add utility to this data and make this data really useful to the parents, to the physicians, to the clinicians, and everyone in this care ecosystem, all to make this one person have a better experience in their life. And we do so because we're able to focus on key metrics that are well known in the industry, but have always been analog. So I go back to creating your own data. We have this potential to create this wonderful, perfectly labeled database. We have a diagnosis, we have an age, we have a gender, we have all the demographic information, we have medication information. Then we add into it behavioral information. So most people know when you don't sleep very well, you have trouble paying attention in school, you have trouble behaving like you're supposed to or expected to. We capture all of this rich information, and it's all already labeled. And I think about our company in sort of three phases, and I think we're in phase one right now, which is I call it human-defined insights, but it's really that's the value out to the customer, where we can say you can see these two lines going up and to the right. That means things are going pretty good. When a line dips, you start to understand. Okay, well, my sleep wasn't so good this week. What else isn't going well? Well, I noticed that I'm sleeping 2 hours a week less, and we're not eating as well, or we're having more trouble in school. The soccer coach said they just weren't listening today. Instead of that initial emotion and anger that can often happen, or resentment that can happen with a parent and their child, instead they're able to say, well, no, I understand what's happening. I can take control of what's happening. I understand that we didn't sleep that well today, and that's why these things are happening. I need to work on sleep. We need to work on sleep. So we're in this moment where we're creating, I call it trust and consent. So at first, we have to tell the parent, the patient, the therapist, the clinician, what's happening. We have to tell them that we are collecting all this information, and we have to remind them that this information belongs to them. If they need it destroyed, it gets destroyed. If they need it transferred, given to someone who is outside of this system, we'll inform them about the risks of sharing that information, but allow them to do that and really empower them. And that's where you move sort of from consent into trust. And trust is immensely important when it comes to artificial intelligence, because most specifically, it's artificial. It's not our thought process. It's a thought process that exists outside of our brains, and it's a thought process that oftentimes we can't interpret. So especially when you get into deep learning, it's really good at problems that human beings aren't really good at explaining why they're good at them. The famous problem is the Go game. It's a Chinese board game that's ridiculously hard, and the best people in the world at it can't really explain why they're so good at it. And yet Google can beat them every time. So when you look at these problems, you have to have trust in order to solve them. And in this first phase of our company, we're establishing trust. And in doing that, it gives us the right to gather this labeled data from our users in this immensely complicated, immensely sensitive industry. And then when you move it in the second phase, now we have this permission to say, we notice you're not sleeping so well. We also know that when you don't sleep well, based on your last year's worth of data and other people who look a lot like this patient, they don't perform well in this particular way. Let's focus on that thing today. Let's focus on school, because we know that when you're not sleeping well, school is where you suffer the most. And sometimes that perspective can't come from the parent. It can come from other people in the ecosystem. So for us, it's immensely important to gather information from other people in the ecosystem in order to assess the true success. Assessing success, that's not, those words don't go well together. So in order to assess the success of this particular metric, you have to capture the whole ecosystem and deliver insights to the whole ecosystem. So in this first phase, we're collecting information, we're gaining trust, we're gaining consent. Well, we've now moved into this second phase where we are delivering our own insights based on your information and everyone else's information. Oh, gone. So my point is that these ethics are not just something that I'm thinking about. I'm sure that the Kevins up here with me are considering them deeply. But it's also something the entire industry is working on. There's a number of different consortiums out there. I want to make sure I hit on this. I think it's really important for everyone to understand in this, is that the data science world has started to take responsibility and started to take the initiative to set principles for the entire industry, set principles for the business people who might not quite understand the technology themselves, but can understand the impact they can have, so that we can have socially responsible businesses that prevent giant robots with guns from killing all of us, which is a good thing, I think we can all agree. But also from making the wrong diagnosis or suggesting the wrong thing, they can lead to adverse side effects. I'm going to kind of stop there because I know there's lots of other smartness up here that wants to share as well. So I'll hand it over to the other Kevin.
Great, thanks, Ben. I think so. I'm going to introduce Kevin Lawver now. Ben touched on like the ethics of AI, and as we were planning out this panel, that was something that all of us wanted to touch on. So if you have any questions about that, we've mostly been talking about tech so far, but ethics is a big one too. And now over to Kevin.
Hi, my name's Kevin. So at Planted, we try to help people get hired, and people hire the right people. Help companies hire the right people, and that's traditionally a very hands-on. I look at your resume. I don't know why I want this resume to move forward or not move forward. There's lots of implicit bias. There's biases we don't understand and why people don't move forward or do move forward. And so I want to talk, my main point, I do mostly data accessibility. So we have lots of data. I need to make that data accessible to the rest of the company so they can understand it and we can find the value in it. And then we can train algorithms to do that prediction for us. So I call it unstupiding. So we do lots of manual processes. I come along behind and automate them away so they're less stupid, and people can spend more time being smart than they can being stupid. So if you're just getting started and you have a business, you have lots of data. So your first job as a potential data scientist is doing a data audit and figuring out what data you have. If all of your data is unformed, you might want to start labeling it. If you don't know what your users are doing with your product, you might want to start tracking it. If you don't know how long your products stay in your database, you should start, so like measure everything, because you don't know which piece of that data is going to end up producing a valuable insight once you apply machine learning to it. And then there are lots of different kinds of problems. We sort of didn't talk about, like, we talked about image classification, but there's data classification. There's like the linear algebra classification, like real estate. And it's like, you have to pick which problem you're trying to predict, and really don't start trying, I want to predict everything. Like, it's hard enough to predict one thing. Just work on one thing and try to make it something that you understand the mechanics of, so you can apply the data to it. And then on ethics, like, I think the way I explain it is, yeah, we have all these biases, and if we're training the algorithm on past decisions, we're probably just making our biases a lot faster. So we're just training it on past performance by flawed human beings, and that might not be the right way. So we need to be really careful about what data we give to the algorithm, and then we need to carefully curate the result as well.
What's an example of that?
So from the recruiting world, if you have a name that sounds not male, you are 30% less likely to get an interview across every industry. It doesn't matter what it is. If your name doesn't sound white in the US, you have a 50% less chance of getting an interview. So if you train your data on names, you've just made that bias not only faster, but now indiscernible. You can't go, like, neural networks are a black box. You can't go interrogate every neuron and go, why were you so dumb? Or why'd you come up with this answer? You've got billions of them. And
So do you take the name out of training data?
Yes.
Okay. Why could you also just increase the weighting on the samples for the non-white men, or would that bias your?
I think it would bias it. And like, that's where like you're trying to compensate for things. It affects everything downstream. So if you know that, like, if you know the statistics,
Right.
you can just remove because I don't think gender or your name is relevant to whether you should get an interview or not. So I would rather just remove that from the entire train. We could train it and see what happens. We go, hey, let's train a racist robot, or a racist, misogynistic robot. That'd be cool. But I'd rather not.
What if I strip the name off of every resume? Could I predict whether or not it's a white male just based on the structure of the content?
Given enough data, yeah, you sure could. You probably could, based on like fraternity, what college they went to, how they described their role. Like, yeah.
So how do you normalize your data?
You have to. You can like, that's part of the understanding the data. So we try to remove the name, we try to remove addresses and phone numbers and personally identifiable things, and get down to, we have recruiters, we have in-house recruiters, so we have in-house experts that we can interrogate, and we do, on why did you pick this candidate? What's important for this kind of role? And then we start bucketing by different types of decisions. So like, hiring a customer service person is very different than hiring a salesperson. So we might train initially across every decision that we've ever made and see if there's a trend. We go, oh no, it's very wrong most of the time. And then you drill down. And
That's something this Kevin brought up earlier, which is sometimes domain experts are still needed in machine learning. It's just that they don't write the algorithm, but they inform the algorithm. They help to improve it, and it's a key component in having those domain expertise is usually essential to doing this successfully.
All right. So Kevin wrapped up. Anybody else? Okay. So we got 14 minutes left for questions. Otherwise, I have some questions for these panelists. So go ahead.
So I know there's a lot of companies buying up data sets like Bayer, for example, companies that you wouldn't expect. What are the data sets that are in danger of being just locked up?
Data sets that are in danger of being locked up. Search, yeah.
Yeah, I'd be scared of things like search data, where you have like the only thing, if you only use Google, if most people primarily use Google, it's the dominant browser, they have the potential to lock up that data, they monopolize the access to that type of information. Or Facebook, what used to be what was your social feed. Twitter started to move into that space. So the competitive data set is almost as interesting as the competitive business model.
So I'll tell you, I don't know if this completely answers your question, but I'll just tell you that a related question we see with our clients is they're worried about non-traditional actors coming into their space. And so bank has got tons of banking data. They get all about, how to target credit card problems. Oh, as it turns out, Amazon, Walmart, and Google have a lot of problems. So they're seeing those companies as potential threats they had never considered, so that they could come in and just wipe them out because their ability to target a credit card offering is so much better than Capital One because they know so much more about you, or things about you that they can collect and make predictions that an insurance company or healthcare company can't legally collect. They can't ask you certain things because it's regulated. But if Amazon chooses to enter the space, they can take your, how much you paid for your power drill and, write you a health insurance policy. So that's where it's more that that I see how data is being exploited more than locked up. I don't know if that's what you guys run into. Good question, though. Go ahead. Okay.
One is in government, usually when you go to these large, historical sets, for example, you get these outliers, and sometimes those outliers are really meant to be discovered, so they sort of block this type of stuff off for corruption, anti-corruption, and on the other side, there's sports. Sports is a hard one because when you get all this data, now there's medical ramifications for ushers and things like that. So I think there's two types of sets before. That would be a good example where we were getting large.
It's a good question. I've never had actually anybody ask me. Most people ask about privacy and exposure, not things being locked up. So, go ahead.
So I'm a UX designer, but what can UX designers and business people and less technical people do to work better with you? What do you wish we knew?
What do I wish you knew? So keep in mind that we're all crawling. So most people say, I'm just a beginner at AI. The smartest people on the planet will say they're a beginner. So we're at the early stages of this. What do I wish business people knew? Man, I don't know even how to start that one. Go ahead.
So Kevin and I actually had this conversation last night because I call myself a business person for the most part, and I think I'm crawling pretty far behind him. But the first thing I did was learn the language. And there's some incredible books out there that are written for non-math people who can learn how to speak the language. And once you can speak the language, you can start to communicate the opportunities in such a rich way. And you can start to really, as Kevin did this great job of outlining the importance of AI. And so much of that is just identifying the opportunity. So become fluent in the language, and then so much other things will kind of light up for you, and you can start to learn it yourself.
So for design specifically, it's so hard to express data in a human understandable way. So Tufty, that was 30 years. We need a new vocabulary, a new design vocabulary for showing people the data in a way that's human understandable. So I think that's a huge design challenge, and the nerds, we're not going to figure that out. We need the designers to figure that out for us.
Yeah, I guess maybe just building off what Ben was saying, we were actually talking about this last night, and thanks for bringing that up, Ben. But I think when you look at the kind of skills you can have, if you kind of rate your skills on any one area from a 0 to 5, so the 5 you're the best programmer ever, and 0 you don't even know how to turn on the computer. There's tremendous leverage from going to from 0 to 1 or 2. For instance, if you understand what training data is, what overfitting is, what a validation set is, these things are actually not that hard to understand once you have a chance to play around. But your ability to influence your career and how the conversation goes up by leaps and bounds. And what I usually end up telling most of our clients is, look, your hardest part is not going to be finding data scientists and programmers. Your hardest part is going to be finding product managers. people that understand the data and understand how to get data sets, understand validation accuracy, what models need. I mean, most product managers that have come through the ranks in the past couple of years are focused on visual product design, iPhone development. But product managers that understand statistics and data and machine learning are going to be worth their weight in gold.
I have a question. So going back to your recruiting analytics, I was wondering, because you mentioned a lot about like people who get interviews, but wouldn't the data of like who's a good employee or who matches the job be more like relevant than who gets the interview, so that you as the person don't have to think like, oh, that doesn't matter, but the data would speak for itself?
So lots of reasons why we choose interview or not interview is, one, we need a lot of data, and a lot fewer people get hired than get interviewed. So for our data set, it was much easier, like we needed enough data to train a model, and we didn't have enough hired or not hired. We didn't have enough hired positive examples to train the algorithm. The results were really bad. So we went down the funnel to interviewed or not interviewed, and we have enough to train on that. The other problem with are you a good employee is that's super subjective, and there's not a lot of good data. We don't deal with the candidate after the hire.
Stop at the
Yeah.
hire.
Congratulations, you got a job. Off you go. Have a good life.
But wouldn't it? So
Yes,
there's
we would
opportunity
love that,
space
but
for-
there's an opportunity for that, and I think that you're going to see companies like ADP that handle the employee life cycle once you're in the door, do stuff like that, where the recruiting agencies, we just don't have the data for what happens after that.
So we got 5 minutes left. I do want to point out one thing that I wrote down questions. So educational resources, by far, the best thing out there, better than my expensive Stanford degree, is fast.ai, Jeremy Howard's online course. It's 100% free. If you're a Python programmer or you can hack around in Python, it is excellent, excellent, excellent. Go ahead.
100 years from now, what are your hopes and dreams and possible social implications of AI?
Oh man, this is not really good enough. So my biggest implication, I think, is jobs. I think there's going to be there's a massive wave of disruption coming. I think that's way more of a bigger issue than AI that kills us all. I think job loss from this stuff, there's going to be some massive disruption that is coming. I don't think as a country we're ready for it.
There's a massive amount of job loss coming, and it's not the jobs you think. It's not manual labor. We will always need manual labor. It's lawyers, it's accountants, it's what we think of as white-collar service economy jobs. Those are all on the fire. They're all ready to go.
Radiology.
Yeah, radiology, all going. And so my big utopian dream is that we don't have to work anymore. We become, if you haven't read Cory Doctorow's Down and Out in the Magic Kingdom, it is the perfect version of what I want the world to be, where we've solved all of the problems that we think are going to kill us all now, and we all get to spend our lives building Woofy, which if you don't, you'll read the book, you'll figure it out. But yeah, that's my dream.
Down and out.
I'll be the token lunatic on the board, because that's always fun. Not anymore, I'm taking your job now. See, there's still human competition, that's still fun. So I go read any of Ray Kurzweil's books about his projections. There is some incredible literature from very, very smart people who are on the bleeding edge of the research that really take strong looks at the social and ethical implications of AI. And they really try to look 20 years out and further. And there's some really great some industry-wide surveys that take that same analysis. I'm personally a fan of the Singularity, and we'll all be digital, and we'll all live these wonderful ethereal lives forever, and all together, and it'll all be beautiful. See, I can be a lunatic.
But I like tattoos.
So, you'll have virtual nachos. It's the best you've ever had. So I love exploring that side of it. It helps you actually think about the here and now really well, and it helps to draw the path from where you are today to where you personally want to take the world. That's what's so powerful about AI. It makes one person so much more impactful than we've ever been. I've chosen to found a place in behavioral health and in staffing, and there's so many very cool places you can make a big impact now and in 100 years.
Got time for one more question, so make it a good one. Who's got a great question? I'm sorry, I didn't mean to put you on the spot.
It may not be great, but
I'm sure it is.
I'm just generally curious, is net neutrality going to impact getting that data that you need for AI?
I don't think so. I think it's net neutrality,
No.
not for the stuff that I do anyway.
No, it'll have other impacts, but not on data.
It's sort of interesting.
So, I'm sorry, that was a quick, it's not a topic I know a lot about, otherwise I don't have a very good answer, but do you have a specific area, like a domain where you're concerned, or just
No, it's just a general.
just general question? Yeah, so, and maybe, unfortunately, that's
I
not
do have one real quick.
Okay.
Real quick answer to that. Net neutrality is, it going away could speed up the consolidation that we've seen in a lot of these players, and that's going to put a lot of our personal usage data in the hands of a few giant companies. That's a huge risk to the end of the rest of the industry. So Amazon has, 60% of the e-commerce market all by itself. If you want to start up an e-commerce company, that becomes much harder when there's a few entrenched players. And now those entrenched players have extra access to that pipe that everyone previously had access to. So from the AI and the data side, I think there's always going to be stuff like Open Secrets or the Bureau of Labor Statistics. The data is always going to be out there. There's always going to be open source people working on this stuff, but the collection of our collective usage of things is being concentrated in fewer hands. And so it's much harder to get a hold of. We talked about with who owns it all.
Great. Well, that's our session. Thank you, Kevin, and not Kevin. Pitch darkness is happening in the Guildhall room in minus 5 seconds. There's free beer, so please come.
Also, if you are headed to Pitch Circus and you would like to earn some karma coin, Geekend's emotional currency of choice, please take a couple of chairs with you on the way because it is starting to fill up over there. We need as many as we can take. So thank you very much in advance if you're able to.